Good morning, boys and girls. Today we are on lesson 26. We're taking a little bit of a break from fractions, but not really. We are going to be going back and looking at division. This time, however, instead of writing any remainders using a capital R and listing the remainder, we are going to review how to write our division answers as mixed numbers. We are also going to do a quick review of the idea of multiples. Let's start with writing our division answers as mixed numbers. Our book says we have been writing division answers with remainders. However, not all questions involving division can be appropriately answered using remainders. Some story problems have answers that are mixed numbers, as we see in the following example. And let's look at it. A 15-inch length of ribbon was cut into 4 equal lengths. How long was each piece of ribbon? Well, in this case, boys and girls, we do want to be using all 15 inches of ribbon. Therefore, our answer will involve a mixed number, and we will solve that together in just a moment. The other example I often like to use with students when we're deciding whether we should write a remainder answer to our division problem or a mixed number is the example of using chocolate chip cookies. If our story problem involves chocolate chip cookies, and let's say we start out with 5 cookies and 2 of us are going to share them, well, you and I could each eat 2 whole cookies. Now, if we were dividing and solving this problem with a remainder answer, we would say we would each get 2 whole cookies with 1 cookie as a remainder. Well, I'm sorry, boys and girls, if we're talking about chocolate chip cookies, leaving a remaining cookie is simply not acceptable. We want to eat every bit of the chocolate chip cookies. Therefore, we are going to find a way to take that remaining cookie and split it into 2 equal parts. We are going to break it right down the middle, and if I'm the lucky one, I'll have a few more chocolate chips in it than you are. We see then that the best way to solve the problem of splitting 5 chocolate chip cookies is not to say that we have 2 cookies and 1 left over, but to say that we each get 2.5 cookies. And if you get to know me very well, you'll know I'll never let a chocolate chip cookie. Now let's go back and look at the problems in our book. Example 1 reminds us that we have 15 inches of ribbon and we're cutting it into 4 equal lengths. Let's begin by putting 15 inside our division box, and we need to split it into 4 equal parts. 4 goes into 15 3 times without going over. 4 times 3 is 12. The difference between these two numbers is 3. There's nothing more to bring down, and our problem is finished. Now, typically, we would have written an answer something like 3 remainder 3, and that would have been our quotient, our answer to a division problem. But in this case, the story specifically tells us we need to use all of the 15 inches of ribbon. Therefore, this will not be an acceptable way to write an answer. To write an answer that involves creating a mixed number, in other words, taking and converting this remainder into a fraction, we simply follow these steps. I'm going to write this problem out again very quickly. We know that 4 goes into 15 3 times, 12, 3. Okay, here's how we create our mixed number answer. We take our remainder, which is 3, and it becomes the numerator. And then we take our divisor, which is 4, and it becomes the denominator. So, if we take 15 inches of ribbon, we split it equally 4 ways. Each piece of ribbon will be 3 3/4 inches. Let's look at a few more examples. In example 2, we are told that a whole circle is 100% of a circle. And we are asked 1/3 of a circle is what percent of a circle? Well, we'll take our whole part, which is 100, and we divide it into 3 equal parts. Let's start dividing. 3 goes into 10 3 times without going over. 3 times 3 is 9. 10 minus 9 is 1, and we bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. We have no more to bring down, therefore our problem is finished. However, we need to divide all 100% into 3 parts. Therefore, this type of a problem clues us that we cannot simply write remainder 1. We can't have any parts left over. We need to divide everything equally. Therefore, our answer must be a mixed number, a whole number combined with a fractional part. In order to determine our fractional part left over, our remainder becomes our numerator, and our divisor becomes our denominator. We now have a mixed number answer of 33 1/3, and the answer to our question of what is 100% divided into 3 equal parts is 33 1/3%. Let's look at one more example together. In example 3, we are asked to write the improper fraction 25/6 as a mixed number. Remember, we can kind of look at something like this both as an improper fraction or as simply a division problem, with this being the division bar. So, let's begin. There are really a couple ways to solve this. I'm going to treat it as a straight-up division problem. 25 divided by 6. 6 goes into 25 4 times without going over. We multiply. We subtract. There's no more to bring down. Our problem is finished. In order to write our fractional part left over, our remainder becomes the numerator, our divisor becomes the denominator, and we see that 25/6 written as a mixed number equals 4 1/6. All right, that's all for fractions as mixed numbers. Let's take a quick review of the word multiples. Our book tells us that we find multiples of a number by multiplying the number by 1, 2, 3, 4, 5, 6, and so on. You have been finding multiples for years and years and years. We are simply skip counting by that number. Here we go. The first 6 multiples of 2 are 2, 4, 6, 8, 10, 12. All we've done is skip counted by 2. The first 6 multiples of 3 are 3, 6, 9, 12, 15, and 18. It's that simple, boys and girls. Example 4 asks, what are the first 4 multiples of 8? You begin with 8 and then count up by 8s until you have a total of 4 terms. In this case, it's 8, 16, 24, and 32. Those are your first 4 multiples of 8. All right, example 5. What number is the 8th multiple of 7? Well, start at 7, start counting by your multiples. The 8th one is 56. I don't think that will cause you any problems. Looking at worksheet A, would you please do problems A, B, C, D, and F? And looking down below, I see we have G, H, and I. Would you please just do G for me? Thank you.